A large spherical balloon is deflating. At time t seconds, the balloon has radius r, volume v. The volume is modeled as decreasing at a constant rate. Using the model, show that this is true. So, okay, the volume is decreasing at a constant rate. That means dv by dt, that is the rate of change of the volume, is going to be a constant, although because it's decreasing, we put a minus in. So it's going to be minus. Now, often I'd use k, but there's a final k in the answer, so I'm going to avoid it because they might not be the same. So I'll say it's minus c, for example. And if I want to find dr by dt, we use the chain rule. It's a connected rate of change. It's going to be dr by dv, dv by dt, just like dy by dx is dy by du, du by dx. So we have this bit, it's just minus c, and that means I need dr by dv. So I'm going to need to write down the volume of a sphere. We're not given this, you have to know it, 4/3 pi r cubed, and then I'm going to differentiate with respect to r. I definitely want to get it in terms of r because the final answer is. So dv by dr, just times by the 3, it's going to become 4 pi r squared, lower the power. And that means dr by dv is going to be 1 over 4 pi r squared, which will give me minus c over 4 pi all over r squared, which is my minus k over r squared. It's going to put in brackets that k is this c over 4 pi. You don't necessarily have to write this step down here. You can go to the minus k over r squared. I do think it's good to specify what k is in relation to our original constant, though. I would strongly advise that. We're now given the initial radius as 4t, so that's r when t is 0. And we're told when t is 5 that r is 20. And we're also told that the volume continues to decrease until the balloon is empty. So that's just saying it's not going to become negative, I think. We're asked to solve the differential equation to find to link r and t together. So I'm just going to write it out again. dr by dt equals minus k over r squared. Now we cannot integrate this as it stands because the right-hand side is a function of r, which is a function of t, but not just t. So we need to use separation of variables. I'm going to times both sides by r squared. And then you've got two options. You either integrate both sides with respect to t, just recognizing that this actually using a chain rule becomes dr, or you might be somebody who likes to times both sides by dt and then put an integral sign around both. That's quite often taught. It's like maybe arguably a little bit easier to implement, but a little bit harder to understand why we can actually do that. Now I can integrate, so I'll get 1/3 r cubed equals minus kt plus a constant. I did use c earlier on, so I feel like I shouldn't use it again. I'll call it d, the constant. And now I'm ready to sub in some of my conditions. So I know when t is 0, that r is 40. I'm actually very tempted, I'm going to do this. R cubed is just going to then be minus 3k t plus 3d. That's going to be easier to sub in now. So I'm going to get that 40 cubed, which ends up being 64,000, is going to equal 3d. I don't even need to work out d. I actually want what 3d is. So r cubed is going to be minus 3kt plus 64,000. Okay, that's my updated formula. And then when t is 5, r is 20. So that gives me 8,000 equals minus 15k plus 64,000. And I can rearrange, I can do 64,000 minus 8,000. and then divide by 15, which gives me 112 or 11,200 over 3. Thing is, I actually want minus 3k, so if I times it by minus 3, you'll get to being a nice number again. So you might times by 3 after, but I just thought it would be better to do it before. Okay, so minus 11,200. So we've got r cubed is 64,000 minus 11,200t. There's different ways to leave this. I'm going to write it like that. Actually, when I did it myself, I decided it's not too bad to take the cube root, and then I've got a direct function of r. But as long as you've got the equivalent to this and you've not made it unnecessarily complicated, then it'll be absolutely fine. Finally, we're asked to find the limitation of on the values of t for which the equation is valid, and this comes back to it decreasing at a constant rate until the balloon is empty. So we're going to be looking at what happens when r is 0. Because eventually this function would become negative if you just let t get bigger and bigger, because this will become negative. You've taken the cube root of a negative. So when r is equal to 0, 11,200t is going to equal 64,000. So then we're going to get 40 over 7 for t. The mark scheme left it like this. I decided to write it as a mixed number. It's actually 5 and 5 over 7. It's a little bit easier to understand the number of seconds then. So that is, well, basically we can't go any more than that. So what was it? What did it say? Model, find the limitation of values. So values limited to 0 less than or equal to t less than or equal to 5 and 5 over 7. To be honest, that's the one the mark scheme's looking for. It's less bothered about the 0, but I'm going to write for completeness that as our final answer.